Here is my first video making on the MOSFETs. Here we're going to do the DC analysis because there is no AC signal at this point. Now, which MOSFET is this? We know that there are two types of MOSFETs. One is N-channel MOSFET, another one is P-channel. If this arrow is going out, that is N-channel MOSFET. If arrow is going in, that's a P-channel MOSFET. So the other important points, we know this terminal is called gate, this terminal is called drain, and this terminal is called source. Just like base, emitter and collector. So similar to the transistor, but here names are different: gate, drain and source. The important point we should know is the gate current is always zero because there is an insulation here between these two plates. So one is going to be so here this is a conducting plate, this is a insulator. Okay, so there won't be any current passing through this gate. So Ig is always zero. Now there are two modes of operation. One is triode mode of operation, another one is saturation mode of operation. How do you know which mode is which? So here is my notes. In this notes I already posted on the blackboard. So in the triode mode of operation, VGD is always greater than VT. VT is threshold voltage. In saturation mode, VGD is less than or equal to VTN. VTN is the threshold voltage. What is threshold voltage? So a threshold voltage at which a sufficient number of mobile electrons accumulate in the channel region to form a conducting channel. So that's the minimum voltage required to create a conducting channel. And we're going to use this terminology. Kn prime is called process transconductance parameter. That's mu n times COX. COX is oxide capacitance. Mu n is electron mobility. Sometimes that's going to be represented with Kn. Kn is MOSFET transconductance parameter. Kn prime over width over length, where W is the width, L is the length. So I highly recommend you to carry this comparison: triode mode of operation, saturation mode of operation. See the ID, drain current, it has a different equation in triode mode of operation and different current in saturation mode of operation. We always start solving the example assuming it is in saturation mode. If we find out it's not in saturation, then we'll move to the triode mode of operation. Okay, so I will move back to our example. Okay, so back to our example. Here is the given example. Here he's asking about find or define RD value, assuming he didn't say whether it is in active, a saturation mode or triode region of operation. So I'm going to assume saturation mode. I'll start solving for that. So in saturation mode, the current, drain current ID equal to half times Kn prime times width over length times VGS minus VT whole square. That's the given formula. So do I know VGS? Looks like we know VGS value. So we'll figure it out. What is VGS? VGS is 0.8 and VT is 0.5. So if you look into the voltages of two regions of operations, so here as long as VGD, so G is the gate voltage, D is the drain voltage. As long as VGD is less than VTN, then that's saturation mode. Okay. So what we have VGD, so VG and D both are short circuited. So that means, he's saying that VD is 0.8 volt. So VG must be 0.8 volt. So VGD must be 0. 0.8 minus 0.8, which is 0. but our VT is 0.5 volts. So VT is greater than VGD. So definitely this is true. Our assumption is true. We assume saturation mode. So our assumption is true. Okay, assume the saturation mode and start solving the problem. So this is the equation for saturation mode, and in saturation mode VGD must be less than or equal to VT. VGD, we end up with 0 volts. VT is 0.5 volts, which is threshold voltage. So it must be acting in the saturation mode. So ID equal to half Kn prime is given as 0.4 milli. So let me take ID as a milliampere. So I can eliminate that, or I can pull it out, times 4. Now VGS, I have VG equal to 0.8 volt and Vs equal to 0 because that source is directly grounded. So Vs must be 0. So this is 0.8 minus Vt is given as 0.5 right there, whole square. Once you solve for this, I end up with ID equal to 0.072 milliampere. By the way, this is 0.4 milli, so I will end up with it must be milliampere. So I end up with 0.072 milliampere. That is the drain current. Now our goal here is finding the RD value. RD is right there. So that must be 1.8 minus VD must be RD times ID. I know VD value, I know ID value, so I can find the RD. So what is RD? RD must be 1.8 minus VD is 0.8. So that's 1 volt divided by, I have ID as 0.072 milliampere. So 0.072 milliampere. So from this I end up with RD equal to 13.88 kilo ohm. That is the resistance of this RD value. Okay, I will stop this example here. In the next video I will work on another example. Thank you.